Good morning and welcome to this presentation. Thank you to everyone who was able to join us this morning and to everyone who will watch the recorded version. I just wanted to say that this meeting is being recorded and transcribed for everyone's awareness before we begin here. And before we get started, I'd like to point out the Q&A feature at the top of your screen. At any time during this presentation, please leave any questions that you have there, and we'll get to them at the end, time permitting. Alternatively, if you prefer to use the chat function, that would work as well. I'll be monitoring that. This morning here with us is Dr. Jason Huang. Dr. Huang is an assistant professor of mathematics education and researcher at SUNY New Paltz. Today, he's excited to share with us about some of his latest research. We are so appreciative of your time, Jason, and your willingness to spend it with us this morning. The floor is all yours.
Thank you for having me, and thank you everybody for coming. And I just realized that Dr. Ambrose, one of my advisors at UC Davis, is joining us too. So welcome. So I'm going to share my screen and begin my presentation. All right. So the topic of this talk is using EdTech to teach math. Again, I'm Jason Huang. I'm a professor at SUNY New Paltz, State University of New York. I'm in Department of Teaching and Learning. I'm also the program coordinator for the adolescent math education program. So my primary role at the university is to prepare future math teachers. Teachers want to be high school or middle school math teachers. My dual appointment here at New Paltz also allow me to teach in the math department. So that allows me to make sure that there is not such a big gap between theory and practice. I have a strong passion with educational technology, and it might have something to do with my computer science background. I believe that integrating educational technology in the classroom not only can change the way students learn, but also can change the way students see math. And I'm hoping to make that impact. Give me a second. Sorry. All right. So this is a paper that recently got published, the impact of technology artifact on mathematics classroom discourse. This got published 2 weeks ago, so this is like brand new. I'm the first author, and Dr. Scott Sutherland from UC Davis is the second author. The paper was published in Digital Experience in Math Education Journal. So if you recall your experience when you were learning math in either middle school, high school, or college, this picture is usually what happened in the math classroom, that there is somebody, a teacher, instructor, professor, up in the front, and they're teaching. It's usually lecture-based. Usually students were just taking notes, passively taking notes, and trying to make sense of what the instructor had to say. And usually there's a lack of communication. It's usually just somebody, the instructor presenting what he wants you to know. In some case, you might see the second picture, where a student had the opportunity to voice their opinion. A lot of times just yes or no answer, sometimes short answer, and depends on the quality of the teacher question. The student might have some opportunity to express their thinking. But again, the interaction is very limited, usually just between teacher and that individual student. You rarely see opportunity for conversation among students. The students were talking to each other. So classroom can be full of conversation, right? A lot of people can be talking. Not all of them will translate into student learning. So another way to look at discourse in the classroom is, in your first picture, is the conversation based on teacher's idea, the teacher's viewpoint, versus is the idea based on student's viewpoint. Or the third approach, which is the idea dialogic discourse. And what we mean by dialogic discourse is students were bouncing ideas off each other, and they were listening to each other, they were integrating feedbacks from each other, and then they were using that to revise their thinking. So I want to share a conversation I had with my wife yesterday. So as I just mentioned, New York just got our first snow of the year last night. So I was home and I asked my wife, what's for dinner? And she said, fast food. And I said, well, it's snowing. I really don't want to drive. And she said, well, that's what's at home. So I say, what about a leftover pizza? And she says, sure, as long as I'm not cooking. Now, that's an everyday conversation. But if you really pay attention to what we talked about, we took information from each other, and we built the feedback into our dialogue. Unfortunately, these kind of conversation rarely happen in the math classroom. It's usually just teacher talking, or sometimes student providing feedback to the teacher. And there's rarely this interaction that they bounce idea off each other. So that's the discourse type. Now, I start to wonder, what if the conversation is based on different artifact? Now, what I meant by artifact is literally just teacher's work, the art, the writing, the graph, the table, the math symbols. What if the conversation is based on what teacher wrote versus what student wrote? Does it make any difference on the quality of the discourse? And then I started thinking that technology are now in the classroom more than ever. Does it make any difference if the artifact created by the technology is done by the teacher or done by the student? So for example, here you have a screenshot of a Desmo, which is a software that allow users to create a function, in this case, ax squared plus bx plus c. And the users can manipulate the slider to change the value of the variables, the a, b, and c, and observe the corresponding changes on the graph. So does it make any difference if the teacher is creating this artifact and use that to create a discussion, or the student created this artifact and used that to create a discussion? And then I started to think more about this. Well, if we are using technology, what if the technology overlay individual students' work? That the work is not done by a single student, but a lot of students. Would that change the quality of discussion? So let me give you one example on what I meant by joint artifact, which is artifact done by multiple students. So here I have a task. I ask student to give me an order pair. Your y is 2 less than your x. Y is 2 less than your x. So student gave me the answer on the left-hand side. 6 is 2 less than 8. Negative 2 is 2 less than 0. 3 is 2 less than 5, so far and so on. And those are student work. The technology will allow student to plot those points. As you can see, it's just a single point on individual student's screen, and it's not as interesting. But if you actually put those graphs on top of each other, you will get something like this. It becomes a line, and it's not just any line. The y-intercept is -2, the slope is 1, so it's actually a line with a function y equal to x minus 2. Well, if you look at my original task, your y is 2 less than your x. Y equal to 2 less than your x. Isn't that y equal to x minus 2? So you have that relationship represented in a graph, in order pair, and also in the wording of the problem itself. So what interests me is, what if the discussion is based on these joint artifacts? where it's constructed by a lot of students, does it make any difference on the quality of discussion? So before I move forward, I want to emphasize that I know a lot of my audience today doesn't have a strong math background. So I want you to focus on the relationship between artifact and the quality of the discourse, and not on the math itself. All right, let me give you another example for joint artifact. I asked students to create I pre-built the digital worksheet with b squared minus 4ac, and I asked them to drag around the slider and manipulate the value and create the b squared minus 4ac that's less than 0. So on the left-hand side, you see 6 students' work. These are all discriminant that's less than 0. Again, by itself, it's not as interesting. But when you overlay that, you see this pattern that none of the graph intersect with x-axis. Well, why is this important? Because b squared minus 4ac is part of this quadratic formula that's underneath the square root. And when that is a negative value, you have a negative number in the square root, which makes x an imaginary number. If it is imaginary, you don't have any real root, which means you don't have any x-intercept. Again, you can link between graphical representations with the concept of quadratic equation. The focus of the joint artifact is, I'm wondering, discussion based on this kind of joint artifact, does it make any difference on the quality of classroom discourse? So right now, there's this 2 intersection that I'm interested. The intersection of these 2 circles that I'm interested. On the left-hand side, researchers, educator has been emphasizing the importance of discourse, math discourse in the classroom. It's embedded in standards in Common Core in Engage New York. But teachers also find it very challenging to foster meaningful classroom discourse, especially for pre-service teachers. That's on the left-hand side of the circle. On the right-hand side, more and more technologies are in the math classroom now. And researchers have shown that using technology can improve the mathematics learning outcome for the students. But there's actually not a lot of research talks about the intersection between the 2. How does technology support classroom discourse? And to date, to my knowledge, there's actually no research that talks about joint artifact, the artifact created by multiple students. How does that relate to the quality of the classroom discourse? And that's essentially this paper. So next is the research question, which is kind of a fancier way of framing what I just talked about. How does artifact creation and ownership influence the characteristic of participation in math discourse? And the second research question goes on and talk about the teacher's pedagogical move. All right, participant. The participant of this study are 5 pre-service math teachers. Actually, I started with 12 and ended up choosing only 5 for deeper analysis. These are pre-service math teachers. They are all graduate students. They all came in with a strong content background. So either a bachelor degree in math, in applied math, in statistics, in engineering. And they all want to be a high school or middle school teacher. And part of the program, they are required to take this class that's math-specific educational technology course. It's a 2-semester course in their very last year of the program, along with their student teaching experience. And I was the course instructor. So as part of this course, they are required to design this technology-based lesson. So I first introduced the idea of different type of artifact, and I introduced different type of discourse. And then I asked them to go out here and create a technology-based lesson. After the lesson, they had a chance to practice their lesson, to rehearse their lesson with their classmates. where their classmates play the role of a student. And they reflect on their experience, they have peer review, self-review, they use that experience to revise on their lesson plan. And then they will take that lesson and actually implement it in their placement with real middle school or high school students. So this last part, where they implement it in their student teaching with real high school and middle school student, I video record their teaching. So I have this classroom set of data. From these 5 participants, I have over 300 minutes, around 10 hours worth of data. For the 12 participants, I have like 20 plus hours of worth of data. Because they were actually doing 2 rounds of these technology-based lesson design. And I was wondering, like, what do? I have all these classroom data, all these videos, how do I analyze it? So when I take a video, the first step, what I'm gonna do is I want to eliminate the time where the classroom interaction is not math related, which is the red. For example, there might be the time where teachers take attendance. There might be the time where they are transition between different activity. There might be time where you have classroom management issue, for example. So actually, after I take it out, I also want to take out the time where students working in group or working individually, because I want to focus on they were using technology in the classroom for discussion. So that's the green, individual versus and the groups. And I also want to take out the orange session, which is whole class without technology. So they might have a classroom conversation using whiteboard, and it's meaningful, but not for my research, because I only want to focus on how do they use technology to foster classroom discussion. So after I eliminate the red, the green, and the orange, the leftover is the blue, which is what I really want to focus in. The blue duration of the videos, I need to analyze it through 2 different frameworks. One of them is discourse type, teacher's view, discussion based on teacher's view, discussion based on student's view, or dialogic discourse, where they bounce ideas off each other. The same video, I want to analyze it again using a different framework, artifact types. Are these discussion based on teachers generated artifact, based on individual student generated artifact, or is it based on joint artifact that's generated by multiple students? And this is when so ideally in my vision, I want to create something like this. I feel that if this matrix will allow me to see specific incidents, specific duration of the intersection of different type of coding. So that's the vision, that's the final goal. So I decided to use Vosaic as the software. And one of the reasons I choose this software is because it allowed me to code the videos, and it allowed me to not only analyze the duration of the segment that I'm interested, but also the intersection of these incidents. So to give you a better idea on my coding process, I took a screenshot of part of this whole class analysis. This is about a third of the class that I just shared. So my first step is I'm only interested in the whole class with technology discussion. So identify those segments. And after that, for every single one of these blue segments, I want to analyze it through the framework of artifact type, as well as discourse type. So for example, for this red rectangle, this segment, when I analyze it through artifact types, I realized that this whole conversation was based on teacher-generated artifact. But then when I analyze it through discourse type, Around the first half of this segment is teacher viewpoint. When I was doing the analysis, I call them teacher transmission. And the second half was based on student viewpoint. So again, the software allowed me to analyze the intersection of different framework, different codes. So after going through, so this is one example for the video that I just showed. After I find out individual time duration for different interactions, I changed that into percentage. And I had to do that for all my data, for all the participants, for all their classes. And this is my results. So it's loaded with number. And I was thinking, now what, right? So let's unpack this a little bit. First, if we just look at the columns, teacher viewpoint is 67.5%. Conversation based on teacher idea. So if you recall your experience in learning math, majority of the conversation is based on what the teacher said, right? So this is already really promising for me. 67.5 when they are using digital artifact. A lot of researchers are claiming that teacher viewpoints usually around 85 to 90% of the classroom time. So this is already really promising for me. If you look across, conversation based on teacher-generated artifacts, so whatever the teacher write, whatever the teacher created, it's about 56%, and the other two is about 20% each. But what interests me the most in this data is this 3.1%. Now remember, dialogic discourse, when they bounce ideas off each other, happen rarely in the classroom. What the study found out is it happens almost exclusively based on joint artifact. It's 0.8% based on teacher artifact. And in fact, it's just a single incident. It did not happen at all for student artifact. 3.1% out of 3.9%. Almost exclusively happened when the conversation is based on joint artifact. So then I was thinking, well, does the teacher's pedagogical move make a difference? So I decided to present 6 episodes to illustrate these different type of interactions in the respective code. Due to the time constraint for us, I'm just going to share 3 of the quotes. And again, because the study was done in math, you might find it math heavy. For those without a strong math background, I want you to pay attention only on the relationship between discourse and artifact and not in the math itself. So episode 1, this is a classic teacher viewpoint sequence where teacher use the artifact to show what they want the student to see and to understand. So on the right top corner, you have the decimal slider, y equal to ax cubed plus bx plus c. And the teacher created this, projected on the overall screen, and he was dragging the slider around to show what he wanted the student to see. So I'm going to read part of the transcript on the left. The teacher said, if I move my slider A, what happens? Ashley says, it's moving. Well, and the teacher said, what's happening to the end behavior, to the function specifically? Ashley says it's getting wider. And line 10, the teacher said, okay, end behavior is changing, right? And the teacher paused at 7 and paused at -7, which are the 2 graphs that you see on the right-hand corner. And the teacher started to say that the end behavior looks like when x is approaching negative infinity, y is getting larger and larger, so on and so on. Line 11, Maria was able to summarize what the teacher said using the teacher's language. So again, not getting into too much of the math content, this episode illustrates that the teacher displaying what he wanted students to observe to illustrate the concept. What was interesting is if you look at line 5, Ben was trying to say it tells you the whole something. He was actually trying to interject about the orientation of the graph. And the teacher just ignored it because it's not part of his plan in the lesson design. Episode 4. This is an example, an episode where the conversation was based on student-generated artifact, and student had the opportunity to conduct their experiment and use that results to mediate the discussion. So the table in the middle, you're going to see X from 1 to 9, and this is based on a training run problem. So the X represent how many time of the training. Y represent the time being reported. So ideally, the more you train, the faster you're gonna run. So in the first training run was 8.2 minutes. The second was the ninth run was 6.9 minutes. On the right-hand side, you're gonna see the plotted point of these table values, and then you will see the line of best fit, which essentially is the line that best modeled these plotted point, the relationship. On the bottom, you're gonna see the R value, which we call the correlation coefficient. It essentially is how coherent are these dots with the line of best fit. So if you look at the test in the transcript, the teacher said, I wanted to see how could she run for the ninth to get us even closer to -1. And the student said, I think 7.1 is the answer, but instead of telling student they did it right or wrong, she said, well, let's try it, put it in. And there were, because of the data I had, there were a few trials. Student was giving out different trial results. And all of a sudden, Adam said, I don't think it's working. Justin jumped in and say, maybe we can get it closer to -1. And the teacher followed up by saying, why do you think that's the case? Justin said, only if it is a perfect line, because R value, correlation coefficient, is the value between 0 and -9. I'm sorry, 0 and -1. And if it is a -1, that means every single dot, it's right on the line. So again, not getting into the math too much, I want to emphasize that the students was probably able to generate that result based on their opportunity to try to conduct experiment. And for the teacher, as far as the teacher's role, she knew that this test was impossible, that you could never get a value when you change the value for the 9th round to get to a perfect -1. She knew that. And I know that from the lesson plan. But yet, she still gave students the opportunity to try to investigate. So instead of telling students wanting to know, she enables students to actively explore the concept through technology's feedback. And that gives students the ownership. The conversation right here was teacher-driven, yet it was based on students' idea. Episode 6. This is a statistic problem, the Fung's needles theory. So if you take any object and you double the length of the object and you create a parallel line like picture 1 on the top, when you threw the object randomly on the paper, like the picture on the right hand side, the ratio of the total matchstick used, in this case, 30 matchstick was through on the paper to the matchstick that crossed the line. So there are 8 matchsticks that crossed the line in our example. So the 80 divided by 8. That ratio should be expected to approach to the number of pi. In our case, it's 3.75 because we have small sample. But the more trial you have, the larger sample you have, that ratio is supposed to be approaching to pi. If you look at the value 33.75, the teacher had students conduct this experiment by themselves. And then plot these points. 30 are how many matchstick was thrown, and 3.75 is the ratio. Student did this on the paper and also on the technology, and then they created this image on the right-hand side. So let's start from the top. Leslie said, "What's the question?" And the teacher said, "No question. I just want you to discuss what you see. Go." Gary makes the claim that the higher we went, the closer the average gets, which is the idea of the law of large number in our case. Leslie replied, "Can you repeat what you said?" And Gary did. But Harold jumped in and said, "Well, why is this point, the 600 closer than the 800, which is the dot on the left-hand side? It's closer to the line than the dot on the right-hand side. Because supposedly the more trial you have, the closer to 3.14, which is the line." And Gary was thinking about it, I think, because he's saying, and then he take the feedback and revise his thinking and said, "I think it's because it kind of goes up and down." And Joshua was able to summarize based on everything he heard. I feel like it's like the randomness of it. If you look at, again, not getting into too much of the math content, if you look at this conversation, Harold was able to come up with a counterexample based on technology's feedback, using technologies to make the argument. And Gary was able to take that feedback and revise his thinking, and Joshua was able to generalize the results. So they were bouncing ideas off each other. This is why I called it as dialogic discourse. Students were relying on peers' interpretation of the artifact to investigate, and to develop their understanding. All right, findings. First, digital artifact supports the fostering productive math discourse. And we anticipated that. But we also found that discourse is more likely to be based on students' idea when it's using students' artifact. So when students have ownership of the artifact that they created, that translates into the ownership of their discourse. Second, we found that dialogic discourse, which happens rarely in math classroom, occurs almost exclusively when it's mediated by joint artifact, which is artifact created by multiple students. We found that artifact is only responsible to create a space, and it requires teacher facilitation. So between the two episodes, the first one, teacher's approach was really teacher-led. This is what you want to see. The second approach is go figure it out and let's try it. So teacher's pedagogical move makes a big difference. More interestingly, we found that joint artifact itself might contain this agency. So let me shift back real quick. Notice in this episode 6, all teacher said is there's no question. I want you to discuss what you saw here. And she didn't get involved. The students were able to create dialogic discourse. So I'm trying to argue that the teacher's facilitation at the moment of discourse might not be necessary if the teacher already create a classroom culture of discourse. So let me give you a little bit background. The teacher before this episode was making a statement like, "You're not talking to me, you're talking to your classmates," to make sure students are talking to each other. He also makes statements that there's a lot of claim going on. Nobody's using technology as evidence to explain their thinking. So he encouraged students to use technology to support the construction of their arguments. Once those classroom norm is created, maybe there's a possibility that the joint artifact combined with the classroom norm can replace the at the moment teacher facilitation. Limitation of the study. This is a small sample. We only have 5 participants. So a larger scale study is recommended. Could be for more pre-service teacher or for more experienced in-service teacher. And when I say experience, it could be mean the experience as far as teaching years or experience as far as their comfort level with EdTech. Another limitation is this study shares what a teacher did and how did they do it, but not the why. We don't know why the teacher choose those approaches. So it will be worthwhile to investigate the relationship between the teacher's perspective, what they are thinking, versus their teaching practice, how do they actually teach it. And again, this is another screenshot of the publication. And I'm more than happy to share the paper with whoever is interested. Thank you.
Okay, thank you so much. My camera's turning back on here. Thank you so much, Jason. That's incredible information and knowledge that you're gaining through this research. I did have a question about one of the more technical aspects of your research. Specifically, when you're mentioning joint artifacts, you gave us an example there of that overlay. I was wondering, were joint artifacts created when students were working in groups, or were the joint artifacts created after students had worked individually and then their artifacts kind of were overlaid on top of each other?
So the example I provided was individually, and you overlay their results. That said, I can see that happening in a group setting too. So in a group, the whole group might only have one device, and that result could overlay as for individual groups results. So it could go either way.
Okay, awesome. I just want to remind anybody, if you have additional questions, to please put them in the chat or that Q&A function. That would be great. I think I've muted you all for this. You may be able to unmute yourselves, but I'm not sure. So if you can't unmute yourselves, just put your question right in the Q&A or the chat. Yes, I see you've raised your hand. Are you able to unmute yourself, Rebecca?
I think so. Can you hear me?
Okay, great. Yep, awesome.
So it's great to see you, Jason, and so exciting to see you moving forward with your research. So I'm curious about the pre-service teachers and whether, how you set them up in order to do this joint activity.
How I set it up. So in my class, first I modeled how technology is being used. So to me, introducing the technology is not just offering the affordance of what technology can do, the functionality of what technology can do, like different features. It's also about how do you use the technology. So there's this teacher's perspective, the pedagogical approach, and understanding the affordance of the technology to fit the student's need or align with the learning objective. So that's why I feel it's important for me to model it. After I modeled it, I give them the opportunity to design a lesson, to rehearse that in class so we can provide feedback from both me, the instructor, as well as their classmates. And then they have to integrate those feedback, write about it, and actually implement it in their classroom. And they did this twice, one in the first semester and one in the second semester. So that's the setup.
So I have a follow-up. So was the assignment to them that they should use something that had joint activity, or did you let them pick whatever kind of Desmos lesson they might want to choose?
Good question. They were asked to either create, adopt, or revise Desmos lessons based on their comfort level. I modeled a lot of use of this overlaying feature in Desmo, but it was not part of the requirement. And only three out of the 5 participants actually used the overlay. Mm-hmm. And in fact, one of the episodes was the student was using the overlaying feature, but it's still teacher driven. Mm-hmm. So the pedagogy still plays a crucial role.
Well, I have one more question, and this is more of a Vosaic question. Are you getting your students to use that too, or are you the only one that's doing that kind of coding?
That's me. I'm the only one who's using it. I will say that SUNY New Paltz is integrating a software called Panacto, where students are able to go on the video and tech moments and provide feedback on the moments individually and as a peer. So there are actually discussion based on the moment that's being tagged, but that's not that's supported by the university.
We have someone in the chat asking for your paper so that they can read it. I definitely think that's something we can provide, Jason, if you are okay with that.
If you can give me your contact information, your email, I'm more than happy to share my work.
Okay, and I can send that on as well. Great. I'm not seeing any further questions.
I have one more.
Great. Yep. Feel free. This is great.
Jason, what's next for you in this research?
So the next for this research is and this is actually in progress, that I want to look at not only what happened with them in the classroom, but what happened with them during the rehearsal process. So I'm recording their rehearsal, I'm going through the same process, and I'm also collecting data after they go into student teaching. So that shift between their practice during the teacher preparation program versus when they are doing student teaching versus hopefully when they are out there teaching full time.
And do you have funding for this, or are you funding it yourself?
I don't have any funding for this, but I do have IRB.
Did you get IRB for all the kids in the classroom too?
In the classroom, well, in my class and during student teaching, I do.
Wow, that's a lot of consent forms. Well, it's so good to see you.
Very good to see you.
Okay, thank you very much, Rebecca, for your questions. Thank you again to Jason for giving this presentation, again, taking time out of your day and previously to prepare this and make it concise for us to understand. That was really insightful. Yes, everybody have a great day.